Okay, Algebra 2, this is the attributes and transformations of cubic functions. Once again, this transformations is something we've dealt with over and over. It's just going to be the same rules, but we're dealing with cubic. The parent function for cubic is f of x is equal to x to the third. As far as translations, if you add a number at the end, it's going to go up. If you have x to the third minus a number at the end, it's going to go down. If you have a number trapped inside with x, remember this is a horizontal move, and horizontal moves do the opposite of what you would expect. So if it's x minus c to the third, it's going to go to the right. And if it is x plus c to the third, it's going to go to the left. Your stretch, compression, and reflection, if you have a number in front of x squared and it is bigger than 1, it is a stretch. If it is a fraction, smaller than 1, it is a compression. And if it is negative, it is going to reflect over the x-axis. If you have a coefficient trapped inside parentheses with the x, it is a horizontal, and it does the opposite of what you would expect. So if it is bigger than 1, it is a horizontal compression. If it is between 0 and 1, in other words, a fraction smaller than 1, it is a horizontal stretch. And if it is negative, it reflects across the y-axis. So basically, it's hard to tell just looking at the graph because a vertical stretch and a horizontal compression look the same. A vertical compression and a horizontal stretch look the same. But if you're looking at the actual equation or function, you can tell based on where the number is. Okay, all transformed cubic functions have the following key attributes. The domain is all real numbers, always. It's always going out to the left a little bit. It's always going out to the right a little bit. The range is also all real numbers. It goes forever down and forever up. There is exactly one y-intercept. Okay, it only crosses the y-axis once. And there is exactly one x-intercept. It only crosses the x-axis once. And then the last thing is the graph has rotational symmetry around a point. So when you're analyzing the key attributes of the cubic parent function, you're going to look at the function that they gave you, and you're going to consider what the domain is, what the range is, what your intercepts are, and your symmetry. So on this one, they're giving us, they want to know, based on this table of a cubic function, what are the minimum and maximum values of the function over the interval -1 to 4? The interval -1 to 4 is referring to x values from when x is -1 to where x is 4. X would be 4 right here. Okay, as you're looking there, your domain is ARN. This is what we call interval notation. We'll talk about that more later. So for right now, if you want to say ARN, that's fine. The range is also ARN because we've said domain and range are always ARN. The x-intercept and the y-intercept for this graph are both at the origin, 0, 0. The graph also has a rotational symmetry around that point. How do you know the center of rotational symmetry? It's where if you rotate the graph 180 degrees, so in other words, you flip it around this point, it's not really a flip, it's more of a turn, it's going to hit itself. So if I took this 180 degrees this way, it's going to end up covering itself back up. As x increases, the value of x to the third also increases, so that means it's curving upward. And your minimum and maximum values of the function on the interval occur at the endpoints of the interval. So let me erase this where you can actually see the graph again. And our interval is from -1 to 4. So if you put -1 in, you get -1. So -1, -1. And that's your minimum value. And then if you put 4 in, you get 64. And so that's where your maximum value is. Okay? So when we found the minimum and the maximum values, we simply put those numbers in to the function. All right, going to the next page. How does the y-intercept change under each transformation? What happened here? My graph went up 1, and so the y-intercept went from 0, 0 to 0, 1. What happened here? My graph went down 8, so the y-intercept went from 0, 0 to 0, -8. So if I had y is equal to x to the third minus 2, what would happen to the y-intercept? It would go down 2, and it would be at 0, negative 2. So how do the intercepts change under the transformation given? Next, we have a number that is trapped. That means it's horizontal. That means it does the opposite. So basically, this is going to go to the right 2. And so from 0, 0, it's now going to be 2, 0. This also changes your y-intercept. And the best way to get that is to look in your calculator. Go to y equal. Let's clear everything out. And so we have open x minus, go back to y equal. We have open x minus 2, close rooftop 3. Let's go to our table. The y-intercept is going to be where x is 0. And let's just tell our table to start at 0. And if x is 0, it's negative 8. And so that's how I know what my new y-intercept is. Okay. This one, we know that it's going to go left 3. Okay. And so, I'm sorry, where am I getting the 3? It's going to go left 1 because of this number right here. And so the new x-intercept is negative 1, 0. Once again, you're going to want to go to your calculator to y equal and put it in. So we're going to say plus 1. We're going to go to our table and see if x is 0, y is 1, and so the y-intercept changes to 0, 1. So if I had y is equal to x minus 4 cubed, I know it's going to go right 4. So that means that my new x-intercept is going to be at 0, 4. I'm going to want to go to my calculator, and I'm going to make it say minus 4. I'm going to go to my table, and it's going to be negative 64, so my y-intercept is going to be at 0, 64. I don't know if y'all caught that, but I did write this wrong. This would not be 0, 4. This would be 4, 0, because it was a horizontal move. I changed the x. Okay, so then we want to talk about the symmetry change. So how do you know the symmetry of the graph does not change, or if it does? Once again, when you transform it or you rotate it 180 degrees around the origin and it hits itself, then the symmetry does not change. If it doesn't hit itself, it would. Now this is transforming it or rotating it around the origin. So if you look at this one and you put it in your calculator at y equal, and we're going to say 0.5 x to the third, and you go to zoom 6 and look at your graph. If you rotate it around the point on the origin, it still hits itself, and so it's unchanged. So if you do negative 4x to the third, negative 4 x to the third, and you look at that graph, and it's still, if you rotate it 180, it's still rotating around the origin, so it is also unchanged. All right, going to the next page. We have 1/2 x quantity raised to the third. This is going to be a horizontal compression, a horizontal change, because it's trapped in there. Both of these are actually. And the way you know is because it's trapped inside. Okay, now keep in mind that a horizontal stretch is the same thing as a vertical compression. You can't tell the difference just looking at the graph whether it was horizontal or vertical. But it does not change the symmetry of the graph. Okay? So looking at these, it wants you to analyze how the intercepts change based under this transformation. So we're going to go to y equal, and we're going to put in x to the third plus 8. Okay, well, we should know that since it's plus 8, that it's going to go up 8. And so your y-intercept should change, right? Y-intercept is going to go, and it should now be at 8. And your x-intercept, and so sure enough, x is 0, your y-intercept is now 8. Your x-intercept is also going to change, and you're just going to have to find that on your table. You look for where y is 0. So your x-intercept is now -2. So your x-intercept is -2. Your y-intercept is 8. So for number 2, this went down 27. So your y-intercept is going to be at -27. We're going to go to y equal, and this was x to the third minus 27. We look at our table, and so sure enough, the y-intercept is -27. We've got to look for where y is 0, and so my x-intercept is now 3. X-intercept is equal to 3. If you want, you could have just written x equal 3, y equal -27. Okay? If you have x plus 2 quantity to the third, so you're going to go to y equal, and you're going to clear it out. X plus 2, rooftop 3. Go to your table, and -2 is your new x-intercept, and 8 is your new y-intercept. You knew the x-intercept became -2 because this was a horizontal move. And so x equal -2, y equal 8. X equal -2, y equal 8. You're going to be able to tell one or the other, possibly both, by looking at the equation. And then the other one you got to get from the table. This one is going to the right 4, so x should be equal to 4. But let's go look and see. Y equal, and it is x minus 4. And so if we look, sure enough, x equal 4, and then y is equal to -64. Y is equal to -64. So on this one, we're going to the right 1.5, so x should be equal to 1.5. And then we're going to have to go and look at the table to figure out what the y one is. So this was x was minus 1.5. Go to your table, and it's going to be -3.375. -3.375. Okay, this one has two things going on, so let's just kind of go to our calculator to start with and figure this out. Looks like it could be x equal -1 and y equal 1, but let's check and see. Okay, open x plus 1, close rooftop 3 plus 1. So we're thinking x equal -1 and y equal 1, and it's not, okay, because two things are happening. We've got the +1 inside and a +1 at the end. So you can't, when there's two things, just go with that. It's going to be x equal -2 and y equals 0. X equal -2, y equal 0. So analyzing how your symmetry changes, you're going to want to put it in at y equal. So we're going to say 1/3 x to the third. And we're going to look at our graph. So I'm going to turn that off. And here we go. And if you rotate it 180 degrees around, 180, it's going to still match up. So it did not. So for number 7 here, you would say no change. If we have -x to the third, -x to the third, look at your graph. If you rotate this 180 degrees around it, there is once again no change or none. You have -5x to the third. Look at your graph. Once again, no change. All of these are going to end up being no change. Because each one of these, when you put it in and you look at it, when you rotate it, it stays the same. Okay, so this has you ready to get your assignment and get started on that.